Welcome to this lesson on independent and dependent events. Still dealing with probability. We're going to talk about what it means to be an independent event and what it means to be a dependent event as we discuss probability. Events are independent events if the occurrence of one event does not affect the probability of the other. As an example, if a coin is tossed twice, it's landing heads up on the first toss and landing heads up on the second toss are independent events. The outcome of one toss does not affect the probability of heads on the other toss. To find probability of tossing heads twice, multiply the individual probabilities. So when we have independent events, all we have to do is find the probability of A, find the probability of event B, and multiply them together. So we have two separate events. We're going to multiply them together after we find the individual probabilities of each one. So for example, it says find the probability of spinning a 4 on the first spin, then a 4 again on the spinner on the second spin. Well, there are 8 spaces here. There are 1, 2, 3 4s on the spinner. So the probability of spinning a 4, we'll call that event A. It's going to happen first. Would be 3 out of 8. Then we go and we spin it again. Now, whatever happens on the first spin does not affect the outcome of our second spin. So the probability of event B, of spinning a 4 again, well, there's the same amount of 4s on the spinner. So it would be 3 out of 8. So the probability of spinning a 4 and then a 4 again, we're going to multiply those probabilities together. It's going to be 3 out of 8 times 3 out of 8, which would leave us with a probability of 9 out of 64. Well, let's find the probability of spinning red, then green, and then red on the spinner. So the probability of spinning a red, typically we put probability of big P, parentheses, and we put the event. So probability of spinning a red would be 2 out of 8 or 1 out of 4. The probability of spinning a green, first spin does not affect it. So the probability of spinning a green would be 3 out of 8. And the probability of spinning a red, it's not affected, so it's the same as before. It's 1 out of 4. So these are 3 different events. We're going to multiply them together to figure out what's the probability of all 3 of these things happening. So spinning a red, we get 1 out of 4. Spinning a green, 3 out of 8. And spinning another red on the third spin would be 1 out of 4. So we multiply across the top, we have 3 on top. We multiply across the bottom, we have 8 times 4, which is 32, times 4, 128. And we cannot reduce that. So the probability of this event happening would be 3 out of 128. So let's do this last one. I'm going to explain. We're rolling a 6 on one number cube and a 6 on another number cube. So they're 2 separate number cubes. You're rolling to get a 6. So the probability of rolling a 6, these are independent events because the first roll does not affect the second roll. So the probability of rolling a 6 on a number cube is there's a 1 in 6 chance. The probability of rolling a 6 on another number cube is 1 out of 6. So the probability of taking both of those number cubes, rolling a 6, event A times event B, 1 out of 6 times 1 out of 6 would be a 1 out of 36. We're going to shift gears to dependent events. events are dependent if the occurrence of one event affects the probability of the other. I'm going to give you an example. Suppose you got 2 lemons and 1 lime in a bag. So I'm going to show you this bag. We got 2 lemons in here and 1 lime. So the probability right away of pulling out a lemon would be 2 out of 3. The probability of pulling out a lime would be 1 out of 3. Now let's say you want to pick a second piece of fruit. Well, if you want to find the probability of, say, pulling a lemon out and then pulling out another lemon, well, on the first pull, you have a 2 out of 3 chance of pulling out that lemon. On the second try, well, you've got a lemon and a lime still stuck in the bag. So you would have a 1 out of 2 chance. So the probability of pulling out a lemon first is 2 out of 3. And then pulling out a second lemon, it's affected, so it's a dependent event. So we assume that that lemon was pulled first, and we would multiply with the probability of 1 out of 2 to get a probability of 2 out of 6, or 1/3. Now this is what happens when we assume. So the formula for figuring out dependent events, we use what's called conditional probability. And it's this fancy way of writing it here. It's probability of B with a straight line, A. This means the probability of B given that A has occurred. So we assume that event A occurs in a dependent event. And then we think about, well, what would the probability of B become given that A occurred? So what would the probability of pulling out a lime given that we pulled out a lemon to start with? Or what's the probability of pulling out a lemon if we already know that we're going to pull out a lime on the first try? So let me dive into an example here. Let's say we have 2 number cubes are rolled, 1 red, 1 blue. These events would be dependent because it says, what is the probability that the red cube shows a 1 and the sum is less than 4? Well, event A is that the probability that the red cube shows a 1. If we look on here, how many times does a red cube show up as a 1? Well, it shows up 6 times out of 36, which reduces to 1 out of 6. So you can think you have a 1 out of 6 chance of the red cube showing up as a 1. Now let's assume all of the events where the red cube shows a 1. That is these 6 events right here. Each one of these, the red cube shows a 1. Now it says the red cube shows a 1 and the sum is less than 4. So let's pick out where the sum is less than 4. Well, if the blue cube is a 1, that's less than 4. There's 1 try. 1 plus 2, that's less than 4. 1 plus 3, that's equal to 4. That's not less than 4. So the probability of event B, given that A occurs, so given that the 1 shows up on the red, we have a 2 out of 6 chance that the sum would be less than 4, which is 1 out of 3. So when we multiply those probabilities together, we have 1 out of 6 times 1 out of 3. So there would be a 1 out of 18 chance that the red cube shows a 1 and the sum is less than 4. Let's check out about this example. 2 number cubes are rolled, 1 red and 1 blue. Explain why the 2 events are dependent. So if we want the red cube shows a number greater than 4 and the sum is greater than 9. These are dependent events because the outcome of having the sum greater than 9 depends on the red cube showing a number greater than 4. So on a number cube, there are two numbers bigger than 4. So the probability of event A, we're going to call that the red cube showing a number greater than 4. That would be a 2 out of 6 chance, which is 1 out of 3. Okay. Now, the probability of event B, given that A occurs, means that, well, what's the probability that the sum is greater than 9, given that the red cube shows a number greater than 4? Here's why I have all these written out for us. If the red cube shows a 5 or a 6, those are my 12 options of a red cube showing a number greater than 4. Now we need to highlight the options that give us a sum bigger than 9. 6 plus 6, that's bigger than 9. 5 plus 6, 6 plus 5, 5 plus 5, 6 plus 4. All of those have a sum bigger than 9. When we get to 5 plus 4 and 6 plus 3, that's equal to 9. It's not bigger. So the probability that event B happens, we get a sum bigger than 9, given that A happens, we had a number, red cube show a number bigger than 4, is a 5 out of 12 chance. So there's our two probabilities. We're going to multiply them together, and we're going to get 5 out of 3 times 12 would be 36.